Hello, my name is Wyatt Crane. This is my fourth order low pass Butterworth filter. Okay, so I have a dual op amp here. It's got two op amps in one. Here's the diagram of the op amp. A little bit more expensive, but I was pretty sure it was gonna work out, so it seemed to be easier. Use resistors in parallel and capacitors in parallel and series and whatnot to get closer to my values. This is my oscilloscope that I picked up from a junk store for $20. I don't think they knew what they had, so good for me. I bought this cheap function generator off Amazon. Works pretty good though. And then I'm using a power supply from an old gaming PC build that I have. And I use the power outs. The pins, I use the plus, the minus, and the ground. And then in order to actually get this to output the 12 volts of power, you have to connect these two pins, and then it thinks it's plugged in and it outputs power. So, all right, so let's look at this. When we first input the 50 hertz, our output should be pretty similar since it's such a small frequency input. And so you can't really tell too much of a difference there. But now when we start to go to, let's say, 3000 hertz, we'll see a bit of a difference. You can see there's a pretty clear difference there between the input, which is the bigger, and then the output. You can see that the peak to peak's even a little bit smaller. The delay, let's check 10,000 now, which was the frequency cutoff point. And so I'm expecting this to be about half of the input. So we have our input wave, which is the bigger wave, and then our output wave, which is about half of our input. This is also the cutoff frequency. And so let's check 20K, which was the largest, and the output should be fairly small compared to the input, as you can see.